included, gets about 350 millirems of radiation each year, most of it unavoidable. Cosmic rays shower down on us from outer space, giving us about 30 millirems per year. If you live at higher altitudes, like Denver, you get 60 millirems. Then there are the rocks beneath our feet. Since the beginning of time, radioactive elements in the Earth's crust have been decaying, giving off radiation. Because our building materials come out of the ground, they're slightly radioactive, giving us about 10 millirems a year. Some materials like granite give more. New York's Grand Central Station, for example, emits hundreds of millirems per year. We get about 50 to 80 millirems each year from medical sources like CAT scans and X-rays. And another 30 millirems or so comes from within our bodies.
So when we eat food, a certain part of the molecules in that food, the hydrogen, the potassium, even the oxygen, are very mildly radioactive. So all of us, and all animals and plants, are mildly radioactive, and this has nothing to do with any man-made source of radiation. They always were and they always will be.
But there's one source larger than all these combined. It came to light at this nuclear facility thanks to the efforts of this man, Stanley Watrous. A few years after the 3 Mile Island accident, Watrous, an engineer, was helping bring Eastern Pennsylvania's Limerick reactor online. Watrous showed us what happened next.
All the alarms went off, and the Gerald decided I was highly contaminated my entire body. So obviously that kind of set me back.
Watrous was decontaminated and went home. The next day, it happened again. It happened for 2 weeks.
You again?
Yeah, same old, same old.
Come on over here, let's see what we got. Okay.
Watrous didn't seem to be picking up radiation in the plant. So eventually, he persuaded the health physicists to check out his home.
They took air samples, little grab samples, was the standard norm back in 1984. They took these samples down to the chemistry lab, and they found out that the place was highly contaminated with background radon radiation.
Radon. It had long been known as a danger faced by uranium miners. It's a gas produced by decaying uranium in the soil. But no one suspected that significant amounts built up in houses. Ironically, Watrous had been carrying radiation from his house to the Limerick plant, not the other way around. While few homes have as much as Watrous's, radon collects in all our basements, sticks to all our furnace filters and air vents. How does this source compare with what we get from a nuclear power plant?
Well, typical house in the United States, the annual dose from radon is about 200 millirem, compared to, for the average person in the United States, the dose they get from nuclear power is a small fraction of a millirem. The annual dose from radon is hundreds of times bigger, probably thousands of times bigger. What dose would somebody get if they were living 24 hours a day, 365 days a year, at the closest part of the boundary fence? That's not very realistic, but that's beside the point. They would get a couple of millirem per year. It'd be very small compared to the background radiation.
And ironically, the area around 3 Mile Island is exceptionally high in radon radiation, 4 times the national average, yielding 800 millirems per year. This fact leads nuclear physicist Bernard Cohen to a startling conclusion.
As a result, people living in that area get more radiation from radon in their home every day than they got in total from the 3 Mile Island accident.
Many Pennsylvanians, like Linda Brash, have been actively monitoring radiation from 3 Mile Island since 1979. But have they had their own houses tested for radon?
I have not had my house tested. And perhaps I will someday, but I don't look at it as a, it's not a man-made thing. Radon is part of seeps in through, it's in the dirt, and seeps in through our homes. And we've been building homes for many, 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 many years. Am I, where's my thinking wrong here?
Can human cells tell the difference between a millirem of radiation from a man-made source and one of nature's millirems?
No, there is no logic to that. A millirem of penetrating radiation will do the same amount of damage, essentially, no matter what the source of it is. There's no logic worrying about radiation from a nuclear power plant 5 miles away and not worrying about the radon in your basement.
Nuclear critics concede that a normally operating plant may not pose a major threat. Their biggest fear is what happens if something goes wrong.
Oh my God, Ted, it's that pump.
From the beginning, Hollywood exploited our dread of a nuclear apocalypse. Films like the China Syndrome have left the impression that nuclear reactors might cause devastation on the scale of Hiroshima.
I may be wrong, but I would say you're probably lucky to be alive. For that matter, I think we might say the same for the rest of Southern California.
Yeah, well, first, you couldn't have an explosion like a bomb, like a nuclear explosion. What you really have is a situation where you lose the cooling to the core, and you have the melting of the fuel.
If nuclear reactors can't blow up like atomic bombs, and no one I spoke to says otherwise, the next worst imaginable scenario is a loss of the water that cools the core. When Western reactors lose this water that moderates or slows the neutrons, the nuclear reaction shuts down. That's the good news. The bad news is that the heat from decaying fission products can't be shut off and might melt the fuel rods. The worst meltdown in history happened in 1986 at Chernobyl in the Ukraine. Critics and champions alike were appalled.
Chernobyl was a very large plant. It had been operating long enough that it had a large inventory of radioactive materials in it. It was open to the atmosphere for days, on fire, with plumes of material, radioactive, going up into the air.
Tens of thousands of people were exposed to high levels of radiation, some of them up to 50,000 millirems.
There's nothing deadlier than a long-lasting, highly toxic ingredient that does not challenge your sensory perceptions because you can't see it, smell it, taste it, or otherwise defend yourself against it. And you can see that around Chernobyl now. You've got all these villages and towns that have been abandoned with the creaking doors swinging in the wind and abandoned buildings.
Western utilities say it's unfair to condemn their industry because of what happened at Chernobyl. Unlike Western reactors, Chernobyl used graphite, not water, as a moderator. So the reactor didn't shut down but ran away, setting the graphite on fire. The resulting explosion spread radioactive fallout far and wide.
The Soviet Union, at the time they built these Chernobyl-type reactors, they're so large that they couldn't afford to contain them. Our reactors are much smaller. The pressurized water and the boiling water reactors, the light water reactors are very small, and they're all contained. They have to be contained in order to get licensed.
By contained, Reynolds means that the cores of American reactors are shielded within massive steel and concrete domes. Even if an accident occurred, the argument goes, the radioactive material would be confined inside the plant. But what about a fire?
No, they couldn't catch fire, and even if some of the fuel melted, that fuel cannot get out of the containment into the environment.
The worst accident I can see in a Western reactor is a couple, 2 to 5 fatalities maybe, of people inside associated with the plant. I can't see general public outside the exclusion zone.
Whether you're convinced that a Chernobyl-type accident could or couldn't happen in America, one thing is certain. Chernobyl gave us a worst-case demonstration of just how bad a nuclear catastrophe can be. After Chernobyl, we don't have to rely on Hollywood to fuel our fears. We can examine the real thing. The accident was economically devastating. Thousands of people had to abandon their homes and have a slightly increased risk of cancer. Some children contracted a rare thyroid tumor. Fortunately, it's curable. Despite these tragedies, some scientists argue that the evidence from Chernobyl is reassuring.
That's as bad as an accident can be in a nuclear plant, and worse than any accident in a modern nuclear plant could possibly be. The point is that that reactor was on fire for days and days and days. And yet the number of identifiable deaths from it are really only a handful.
The actual death toll from Chernobyl is surprisingly low. 31 firefighters died in the accident. So far, leukemia and adult cancers have not measurably increased. Terrible as Chernobyl was, there have been many more deadly industrial accidents in this century, like the Bhopal chemical plant accident in India that killed thousands. Supporters of nuclear power complain that if the chemical industry were held to the nuclear standard, it wouldn't survive. Even in America, more than 1,000 people have been killed in chemical plant accidents during the past 40 years. Nuclear executives say their safety record is much better.
In this country, no one has been injured or killed in a nuclear accident involving radiation exposure. No one. But people aren't really good at assessing risk. And somehow we've decided that nuclear power is very, very risky, is a very risky business.
A non-nuclear steam explosion at a U.S. nuclear facility killed 4 people in 1986. But Howard is right. In America, there have been no deaths or injuries from nuclear accidents in commercial power plants. Physicist Bernard Cohen blames the media for singling out nuclear.
The media don't pay any attention to risk analyses. They just say this is radioactivity. They call it deadly radioactivity. I don't know why they call it deadly. It's not killing hardly anybody, if anybody. Nobody talks about deadly electricity, which, although over 1,000 people a year die from electrocution in the United States, nobody talks about deadly natural gas, although I believe it's 5,000 people a year die from asphyxiation from natural gas, things of that sort.
Have environmental groups unfairly targeted nuclear energy?
Well, you'll find actually that Public Citizen and other allied groups have been very active critics of the chemical industry and the aviation industry and the coal industry. So I don't know why you're trying to distinguish among them. We are safety watchdogs, and we're trying to improve health and safety for the American people, and the nuclear industry's record is nothing to shout about.
But still, you're not trying to shut the chemical industry or the aviation industry down, are you?